All right, so we have question 6 remaining to do for this set of questions from exercise 2. So is there any volunteer who would like to do this one, or should I call on someone? What about you, Ms. Cox?
Sir, before you move on, was question 5 right, sir?
Yes, it was correct. Okay. So the answer here is that I naught is the HCF because it is common in all the terms. And so we pull that out, we divide each term by I naught. I naught into itself goes 1 time. keep our sign, and then I naught into I naught alpha t. I naught cancel, leaving just alpha t. So the result would be I naught bracket 1 plus alpha t. And so that would be solution for that one. All right, so who would like to go now for question 6? And I already asked Ms. Cox, can you do question 6 for us?
Sir, I would like to try.
All right, go ahead.
So, sir, for the lowest common factor, the lowest common factor for 200 is 6.
Correction, Ms. Cox, we're not finding LCM now, we're finding HCF. So that would be the highest common factor that we're looking for. And so what that is, it would be looking for common either letters or common numbers that can divide the numbers in each term. But in this case, would you be able to find any number that can divide exactly into 2 and 3, the same number?
Right there, sir, 2 and 3?
Yeah. Can you find a number that will
no, sir.
2 as well as 3? All right, so it means that you don't have an HCF greater than 1. So 1 can divide 2, yes, and 1 can divide 3. But we also need to look at the letters. And so do we see any HCF for the letters?
Yes, sir.
All right, so we choose the lowest power of the common letter. So really and truly, our HCF would be actually 1 for the numbers and A for the letters. However, we won't write 1A for the HCF. We're just simply going to write A, because we know when you multiply a number by 1 or any term by 1, you get back that term. So 1A is just simply A. So our HCF here would be just simply A, which I'm actually trying to write. But for some reason, this thing seems to have a mind of its own sometimes. All right, go ahead now, Miss Cox.
Sir, so the answer would be A bracket 2A minus 3B.
All right, so I just want you to kind of walk us through how you arrive at your answer. I don't want you to just give me the answer just abruptly like that. Just walk us through the process, what you do to get the terms in the brackets.
Sir, 1A into 2A square goes 2A because the A would have canceled another A.
All right.
Leave it to 2A.
So for the first term in the bracket, you will get 2A.
Then minus.
Maintain our sign. And next.
Minus 1A into minus 3AB equal minus 3B.
All right, that would be correct.
Then close bracket.
All right. Thanks very much, Ms. Cox. Yeah, so that would be the answer. Anybody else got that answer correctly? Let me see.
Sir.
Yes.
Question. How would I know when I'm supposed to find the lowest common factor when doing factorization, sir?
All right. So for factorization, you're always finding the highest common factor, not lowest common factor. Why we use highest common factor? Now, as I would have mentioned before, when we think about factors, you can think about the numbers that you multiply to get a product, or you can think about a number that can go into another number. So for instance, here, for the second question where we have 5, 10, and 15 in each term, we are looking for the highest number that can divide 5, 10, and 15 without a remainder. And that would be the HCF for the number. So even though we can use 1 to divide 5, 10, and 15, 1 would not be the highest common factor. So the highest factor that can divide all three would be 5. And so we would have chosen 5 as our HCF. So that's how we find the HCF for the number. If you look at question 3.2 as well, we want a number that can divide 9, 6, and 3, the highest number that can divide all of them. And so we would choose 3 because 3 would be common to all these numbers. So that's how we find the HCF for the numbers. For the letters now, or the symbols, we are just choosing the lowest power of the common letters. And we are going to group the lowest power of those common letters with the HCF. Is that clear, Miss Cox?
Yes, sir.
All right, very good. All right, so I'm going to move along to the next slide. And here I'm going to ask you to continue doing these questions. And I'm going to give you about, pretty much about between 5 to 10 minutes to finish up with this. And then we'll go back through each of these questions. I'll ask individuals to walk me through them. All right, so you can take that time now to work these questions so that we can go back to them. All right, guys, you can go ahead and start working them now. All right, guys, so are we ready to go through this question now? Has anyone completed question 1 and question 7, question 8? At least we can start off with those. Who would like to go for question 7?
Me, sir.
All right, that's no. All right, Mr.
Yes, sir.
Walk us through.
Or for the highest common factor would be X.
All right, so common factor would be X.
X into X to the third power would go X square.
All right, so we have X squared for the first term in the brackets. What next?
And X into X square would give you X.
All right, so X into X squared will leave you with just X.
And X into 7X would leave you with 7.
All right, so from this we have 7. All right, very good, Mr. Ajeno. Everybody got this one correct? Let me see your hand. All right, so question 8 now. Who would like to do us the honors of doing question 8? And the
Like to try, sir.
Miss Williams, all right. Give me a second here. All right, go ahead now, Miss Williams.
Okay, sir. So we have m squared minus m cubed plus m to the 4th power over pn squared p squared n squared. So m would be the highest common factor, and the pn, so it would be m over np or pn.
All right, so you're saying that what would be the highest common factor for the numerator?
M, sir.
You want to check that again?
Sir, M square?
Yes, certainly, because we're looking for the lowest power of m that we have.
Oh, yes, sir.
So it would be m squared for the numerator. And what you have now for the denominator, Miss?
Pn.
Okay, so m squared for the numerator and pn for the denominator.
Yes, sir.
Yeah.
Okay, sir. So the answer would be m squared. So, sir, m squared would cancel out m squared.
All right, and what else?
And then m squared cancel m cubed, so we just have m.
All right, so we can't just ignore the denominator, Miss Williams.
That would be 1, sir.
So for the first term, we would cancel the entire fraction because we have m squared in the numerator and pn in the denominator. So as you say, this first term would be 1.
Okay, sir.
Bracket would be 1. And now next we go to
I
the
would
term now.
put back the sign minus. So m squared into m cubed would just have m.
All right, so continue.
Put back the sign plus.
Finish with the denominator, please.
That's what I'm doing, sir. So you have a plus sign up there.
Yeah, but let us finish up with the denominator.
Right, so m squared into m to the 4th power would have m squared.
Okay, I guess you're not following me. Remember you have a m cubed over pn squared.
Yes, sir.
That's for the second term. So remember, you have to now divide this Pn squared by Pn. So what you get from that?
Oh, I got M square N, sir.
N, right? So this will be M over N. And now you can continue from.
So the next, it would be M square over Pn.
All right, so M squared over Pn. All right. Correct. Thank you, Ms. Williams. Anybody else?
Welcome, sir.
Let me see your hand. All right, so who else would like to go for next question? Who would like to go for question 9? Miss Green, you want to try one of these now? Miss Green,
No,
what are you saying now, Miss Green?
no, sir.
You don't want to try. You don't have a master up enough courage to do one of these.
Not yet, sir. Mommy.
All right, Mr. Giovanni. Question 9.
Yes, sir.
Question 9.
All right, I'll try. All right, so for the numerator, I look for the lowest one. So I is common factor, sir. So that will be x, y.
All right, so that would be XY. I want to have in the denominator now.
2a, sir.
The denominator.
Oh, the 2 squared or 2a? Yeah, 2a.
Would you check that one again?
Yes, sir. 2a.
Would the 2 be common in the
No,
denominator?
sir, it's just A.
Thanks much, Ms. Williams. So the denominator only has a common in all the terms. So it's a common factor. So it's just A. All right. Continue, Mr. Giovanni.
All right, yes, sir. So the x cancel out x squared, leave x. Minus, sir.
All right, so do the denominator at the same time.
Nothing at the denominator or the 2.
So
2.
here you have the HCF for the denominator is A. So you have,
Yes, sir. The 2.
all right, so you have 2 right here.
Yeah.
I hope everybody is following.
Yeah, so x cancel out that, cancel out x. So that'll leave 2y.
All right, so that would be for the next.
Yes,
You
sir.
have what?
So 2y. 2y, sir.
All right. Continue.
And the bottom part are 5a.
All right. So 5A in the denominator.
and plus,
All right. So then,
x cancel out x, so, and y cancel out y, cancel out y cube, so that will leave y squared.
y squared over
And the denominator, yes, oh, a squared, a squared.
Okay. All right, thanks much, Mr. Giovanni. Well done. All right. Let me see the answer those who got this one too as well. All right. Very good, guys. All right, question 10. Anybody want to go for this one, or do I have to call on someone? Mr. Campbell. Mr. Campbell,
Yes, sir.
would you like to do the question?
I'm working on it right now, actually.
So you want to work on it with us?
All right, sir. I know.
All right, go ahead. What you get for the HCF in the numerator?
What's that? Is that IRL? Is that I?
It's
I square
common
M.
L. Common L.
It's common L. And then M. Common L M. Common L square M. Over and then you have 5 as a denominator.
Okay. Continue.
Hold on, sir. I can. All right, so we have 5. So we have open bracket, like, oh yeah, open bracket. So we'll have just M
In the numerator.
in the numerator, yes, sir.
All right.
As well as 3 at the bottom.
All right, so you have 3 in the denominator.
Right. And then we have M again. After you put the sign, you put M again and 4 as the denominator.
All right, so you have, want to check that one carefully?
Oh, all right.
In the numerator, what you have?
The numerator you'll have, oh, I don't think you have anything for the numerator. It's grams M also.
All right, so when you divide an self and what you generally get?
Is that what you see anything, sir?
Sir, 1.
Yeah, 1. Yeah.
Yes, you get 1. So L square M in L square M going to give you 1. So you put 1 in the numerator. Continue.
And you have 4
In the
denominator.
denominator.
Then you will have M again, I believe, yes.
You have M in the.
You have L and then M.
So you have LM in the numerator.
Yes, sir, and then 2 in the denominator.
And then 2 in the denominator.
Yes.
All right. Very good, Mr. Campbell. Anybody else got that? Let me see hands. All right, very good. Miss McIntosh, You have been evading us. Can you do question 11 for us?
Sir, I'm working on it, but I will do it.
All right, so what is the HCF for the numerator?
It was pretty bad. They just get so competitive.
Sir,
in battle.
A square,
All right, so you have a square in the numerator.
B,
A second, we try to write this properly.
Once they're weakened, Hyperion come in and strip them up. What's wrong? I'm just gonna straight up attack them both. Huh? What are you talking about? Did you not see what happened during the last
All right,
battle?
over what?
You and me crash into them head on, we'll have a much better chance at winning. Head on, we'll fight.
sir.
We have to
Yeah,
take
go
it
ahead.
slow and steady. Head on.
Sir, the numerator is supposed to be just A square alone,
You tell
because I'm
me,
not sure.
look and see what is common. What's
B
common?
and C,
Are you sure B and C would be common? When we say
no, sir, no.
the term the letters are common, what we mean they must exist in all terms.
More than one.
In
Yes,
all
sir. So
but
it's A square
A square is common.
over
Kind of similar.
Over.
A square over 2 over 2x 2x cube.
Go ahead.
So A square into A cube give you A.
All right, so we would have A. Do we have anything in the denominator?
Yes, no, sir. 1. It would be 1 or just A alone.
Well, so it would be 1 if you divide the denominator by 2x cubed, but it would be pointless to write a denominator.
1.
Since
Okay.
when you divide the A by 1, you're going to get back A, so you just leave A by itself. So
Okay, sir. Take away B because A square cancel A square, leave it with B over 4x over 2x.
all right, so 2 to 4 goes 2.
Yeah.
X cubed into x4 goes x.
Yes, sir. 2x.
Denominator. All right, continue.
A square into A square, nothing. And that leave it with C over 3x.
Would it be 3x?
Yes, sir.
You want to check that again?
Just 3 alone,
Okay.
because it's x cube.
Okay.
Yeah, sure.
Anybody else got that? Let me see the hands. Thanks very much, Miss.
No.
Let me see the hands that those get who got
Sir,
last one. Yeah.
Sir, so we must not put like 1 under A, sir.
No, you don't need to. Because by dividing by 1, you will get back the same number that you're dividing 1 by. In this case, you're dividing A by 1. So A divided by 1 give you back A. So it would be pointless to write the 1. You follow what you're saying? What's that, Mr. P?
Yes, sir.
Okay, all right. If you put it there, it wouldn't be wrong. But remember, just like when you're writing a whole number, if you put 2 over 1, it would be the same as just 2. So to leave it over 1 would show some naiveness on your path mathematically. So we don't write the 1 because it is already understood that that 1 there, when you divide by a number by 1, you'll get a number. So we wouldn't need to do that. So we just write it. It just looked a little bit more presentable, writing it without putting back the 1. All right. All right, guys. So everybody is good with these. Let me see your hands if you are comfortable with doing these. And bear in mind that, you know, once you learn something, you should keep practicing. You should keep practicing them, students, as you go along. Now, I will make some questions available on the website for you to practice, all right? All right, so we're still on the topic of factorization. I would have mentioned that we have different methods or techniques that we use for different types of expression. So now we're going to be looking at factorizing by grouping. And in this case, we are looking generally on 4-term expression. Now, the grouping method not only applies to 4-term expression, but it applies to expression where you can find pairs of terms that have common factor. And so for 4-term expression, what we're going to do is split the 4-term into 2 pairs. In a sense, we are splitting them into 2 binomial sets that have common factor. So when you look at this pair, you can factorize this entire expression based on the common factor for that expression. For the next pair, we also can factorize this separately. All right, so that's what we'll be doing when we're factorizing by grouping. So in other words, the AX plus AY would represent one group that we're going to factorize independent of the other. And the BX plus BY would represent another group. Now, the process involved first factorizing these groups, and then now from what we get after we factorize these groups, we see if there's any further factorization that can take place. And if so, we continue to do that until we get to our final result. So let us start off with this. So the first pair, we have what is the common factor for the first pair? And the first pair here is AX plus AY. What would be the common factor here?
A.
So it means that we can factorize this pair as a binomial. So